What's up, Bill? All right.
Hello.
Section 2, multiplying polynomials still. This is a continuation from Friday's lesson. And on Friday, just to kind of review of where we've been, on Friday, we introduced this idea of multiplying polynomials. Basically, we are familiar with distribution, the act of distributing using multiplication, which basically tells us that we'll take some object and multiply it throughout several other objects in a parentheses. That's something that you will have been familiar with since middle school. And so the added twist on Friday was that instead of a single object being multiplied by parentheses, now we have a polynomial. And they were relatively small polynomials on Friday. We had a binomial times a binomial. That's simply the name of the type of polynomial it is. And so there was a basic two-step process that we broke down on Friday. And we're going to continue that today, but we're going to add in the fact that what happens if I have a longer polynomial that I'm multiplying by. The spoiler alert is that really nothing changes with our procedure. All that's really happening is that we're just doing the same process over and over and over again a little bit more. Okay, so again, the two-step process we covered was 1, distribute using multiplication, 2, collect like terms at the end. Okay, and we saw that at work when we had two binomials multiplied by each other. We take the first object. In this example, we had 3x. That's the first object in my first parentheses. We're going to take that and distribute that the same way as we always would throughout the next parentheses with multiplication. So in this case, I'd have positive 3x times positive 2x. That gave me 6x squared. Then I'd have positive 3x times the positive 2. That gives me positive 6x. And now that I'm done with that first object, what's changed from the other more simpler versions of distribution is that now I just have another object I have to also distribute with multiplication. So in this case, I would take that positive 1, multiply it by 2x. That gives me 2x. Positive 1 times positive 2 gives me positive 2. And basically, after we're done distributing, we get a long sentence polynomial of all those positive and negative terms that we got as a result of our multiplication. And so that was step 1, distribute, which isn't really that different from anything that you've done before. You just have to do it multiple times. Okay, so you get a longer sentence of multiplication. And now that I have this longer sentence, I want to condense it, if possible, using combination of like terms, which is my second step. And so x squareds can only go with x squareds. It's the only x squared in here, so that travels to the end. X's can only go with other x's, so positive 6x and positive 2x result in positive 8x. And then finally, the positive 2 was the only whole number in this case, or the only number in general. And so that travels to the end as well. Okay, and this would be the collection of like terms at the very end, the simplification of that final polynomial answer. Okay, and we went through a couple of examples on Friday of doing that. And so really there's no major complication thrown in the mix here. It's just you're doing that multiplication over and again. The two things to really be aware of are, first off, you got to get used to multiplying variables times variables. Get used to having these exponents travel along. You will get plenty of opportunity to do that. And the second thing to be aware of is keep track of sign, because as soon as like a negative is thrown in there, it's very easy to lose track of the negatives multiplied by positives, negatives by negatives. Okay, it's just a lot of care and being careful with that, basically. All right, so for today, now we're going to add in another little twist in that we're still doing polynomial multiplication, but now we're adding in multiplying a little bit longer polynomial. And there is no real limit to how long these polynomials can be. You could have, 100 terms times 100 terms. There's no real limit on that. You're just going to end up with an obscenely long multiplication string. But it's just the same process over and again. And really, this is about as long and complicated as you will see in this assignment and what you will see on a test. So it's just really more practice of doing this stuff up here. It's just a little bit longer multiplication sentence. Okay, so let's see this at work. Here in this example, we're given 2x minus 3, a binomial, multiplied by another trinomial, in this case, 3-term polynomial, x squared minus 4x minus 4. All right, so the process is going to be the exact same as these shorter polynomial multiplications. It's just that I'm going to have to do it one more time because there's an additional turnout here. All right, so I'm still going to start with my first object in my first parentheses, in this case, a positive 2x. And that positive 2x needs to distribute through multiplication throughout this next parentheses. The only thing that changes here is that's a slightly longer parentheses than it was before. So that positive 2x multiplied by x squared gives me 2x cubed, right? And I gave you the advice before, kind of separate your numbers from the variables, okay? 2, and then technically there's a 1 in front of that x squared, 1 times x squared. So the 2 times 1 stays 2. And then the x times x squared, that gives me 3x's, or x cubed, x to the third power. Okay, I'm not going to go too deep into that stuff. That's just reminding you of how to multiply these monomials together. But I have 2x times x squared gives me 2x cubed. All right, then I take that 2x and I still have to keep distributing it. So 2x times a negative 4x gives me negative 8x squared. 2x times negative 4 would give me negative 8x. And those three terms will give me my full distribution of that first term. And so now that I'm done with that one, I just move down the line. So my next term would be negative 3. And as we saw before, we're going to be distributing through multiplication again throughout this parentheses. It's just going through the process of hitting each term. So negative 3 times x squared gives me negative 3x squared. Negative 3 times negative 4x gives me positive 12x. And finally, negative 3 times negative 4 gives me positive 12. Okay. Again, I go through this process of showing all the pairings and stuff, mostly just so that you guys can visually see what was multiplied by what. Really, this is unnecessary in your own scratch work and that sort of thing. Most of us can jump directly from here's the problem, here's the distributed answer. Okay. And so we have this long polynomial. It's just longer than it was before for some of these shorter ones here because there was another term. Okay. But now I have to do my second step, which is to combine like terms. So in this case, x cubed or x to the third powers can only go with other x to the third powers. There are no other ones in here, so 2x cubed stays 2x cubed. X squareds can only go with other x squareds. Here are my two objects right there. Negative 8x squared and negative 3x squared. When I combine them, gives me negative 11x squared. Just get used to adding and subtracting with negatives. That's also pretty frequent in this section. All right, so moving on, x's can only join in with other x's. So negative 8x and positive 12x combined to make positive 4x. And finally, there was only one just number, and that was positive 12. So the positive 12 travels on to the very end. And this is what we would call standard form, or descending order, where my exponents, my terms with the exponents that are larger are at the beginning, and they go down in order to no exponents. All right, so we're going to do one example. We'll do this guy right here, x plus 5 times x squared minus 3x minus 2, a binomial times a trinomial. Again, this is about as complicated as you will see in this section and or represented on your chapter 2 test. So I'll go to our solution sheet, also uploaded onto Google Classroom. And so here is our solution to that problem. There's x plus 5 times x squared minus 3x minus 2. Again, we're going to be doing distribution and then collection of like terms. So let's just burn through this really fast. My first term here is positive x. So I'm going to distribute that with multiplication throughout this next parentheses. X times x squared gives me x cubed. X times negative 3x gives me negative 3x squared. X times negative 2 gives me negative 2x. First term done. Moving on to the next term, positive 5. Positive 5 is also distributing throughout this parentheses with multiplication. So positive 5 times x squared gives me positive 5x squared. Positive 5 times negative 3x gives me negative 15x. Positive 5 times negative 2 gives me negative 10. There's our distribution. Long polynomial. We're just looking for common terms now. X cubed can only go with other x cubes. It's the only one, so it stays the same. X squareds can only go with other x squareds. There's my second term right there. Negative 3x squared and positive 5x squared combined give me positive 2x squared. X's can only go with other x's. Negative 2x and negative 15x combined give me negative 17x. And finally, the only number that was left over was a negative 10. again, there's our standard form descending order polynomial result. All right, I'm going to stop recording.